Hi, good evening. The aim of today's lecture is going to be to solve the questions related to risk and uncertainty. Now, as I told you the last time also, every year IIT JAM is definitely going to ask 1 to 2 questions based on risk, uncertainty, and it is going to go ahead and cover topics like, we had discussed this the last time also, but it is going to go ahead and cover topics like expected value, expected utility, certainty equivalence, risk premium, and then you have variance, then you have insurance premium, actuarially fair insurance, and other topics. So basically, these are a few of the important topics from which one of the question is definitely coming. It may not be an MCQ question. They will simply, I'll show you what came last time and last to last time. We'll solve those today. But the aim would be to go ahead and pick up as many questions as possible from these topics. I've made 2 assignments on these. It would be available in your portal. The first assignment is based on expected value, expected utility, variance. The second assignment is based on certainty equivalence, risk premium, insurance premium. So you have to go ahead and also solve those questions from the assignment. I would be giving one additional assignment which would be posted today, which would be assignment 3 based on these topics, which would be a mix of all these topics together. Okay, so let's go ahead and see one by one the different questions that we have for the day. The first question, and you have to go ahead and try simultaneously as I do these questions, is the following. It says, consider a lottery with 3 possible outcomes. The lottery gives 125 with a probability of 0.2. It gives 100 with a probability of 0.3. And it gives 50 with a probability of 0.5. It says, what is the expected value of the lottery? So let's solve this. The expected value of lottery is summation of probability multiplied by the value for each different case. So PI, VI summed up together is the expected value of the lottery. So I'm getting 125 with the probability of 0.2. I'm getting 100 with the probability of 0.3. And I'm getting 50 with the probability of 0.5. So this is the expected value of the lottery. Very simple. Each of the incident that takes place has a corresponding probability attached to it. So I will get this 125 only 20% of the time. I will get 100 30% of the time. I will get 50 50% of the time. So I am just going ahead and adding all of those together, and that is giving me the expected value of the lottery. So just quickly solve this. So this will be 125 into 2 by 10 plus 100 into 3 by 10 plus 50 into 5 by 10. So 250 plus 300, 550 plus 250 divided by 10. So this is going to be $80. So this is just 250, 300 and 250. 800 by 10, which will be 80. So the expected value of the lottery would be 80. That's the first question. Now go to the next part. Just try it simultaneously. What is the variance of the outcome? Now, we know the formula for variance also. So let us go ahead and write down that. So the first part, this is $80. How do I find variance? The formula for variance is probability multiplied by the value minus expected value whole squared and summed up for different cases, I from 1 to n. So in the first case, I have a probability of 0.2. 20% of the time, I receive 125. The expected value is 80. So minus 80 whole squared plus 30% of the time, 0.30, I am receiving 100. The expected value is 80 minus 80 whole squared plus remaining 50% of the time, I am receiving 50. The expected value is 180 whole squared. So this is going to be your sigma square. You can solve for this and you will get $9.75. So this is the variance of the outcome. The variance tells us how much risk exists whenever you go ahead and purchase a lottery. How much is the variation of the outcomes from the average outcome? That is also the variance. The higher the variance, the more is going to be the risk. So, you know, if here, supposedly, you're just given one lottery, right? But supposedly there would have been two lotteries. You would have given that this is case 1, case A, which has 3 possible outcomes. And simultaneously, you would have been given case B with another 3 possible outcomes. And it would have asked you, okay, tell which is more riskier option. You would have compared the variances of the 2 options. And the more the variance would have been, the riskier it would have been. Okay. This is how you can calculate the variance. Now go to the next question. What would a risk neutral person pay to play the lottery? Now here is the thing. This is important. See, who is a risk neutral person? A risk neutral person is indifferent between playing and not playing a lottery. If you are a risk lover individual, if you love to take risk, then you may want to even pay something to play the lottery. Because you want to go ahead and play the lottery. You have preference towards playing the lottery. So if you are a risk lover individual, you will pay to play. If you are risk averse individual, you will be paid to play. So you would get money if someone wants you to play the lottery. So you would be paid to play. Because otherwise you are not taking risk. You don't want to play the lottery. And if you are risk neutral, you neither want to pay nor want to get paid. Because you are indifferent between playing and not playing. And if you were not playing the lottery, Unless the question mentions that, to play the lottery, you have to pay 40 rupees. Unless the question mentions that, indifference always means that you will pay 0 to play the lottery. As a risk neutral person, because you are indifferent between playing and not playing the lottery. So a risk neutral person will neither pay nor be paid to play the lottery. So the answer would be 0. And this is important. It can come in MCQs. So this is important. Please mark this. This is important. Okay. So this was an easy question to begin with. We found out what is expected value, what is variance, and what happens to the 3 kind of individuals. Now let's go to the next question.